these assignments reflect exactly what you're going to find in exams. The type of questions you're answering and how they're supposed to be answered is basically going to be a repetition of such things.
Okay.
Yes. So if you successfully work out the assignments, then you should have no problems with the exam. If you don't work out the assignments, then you have problem with the exam, you have problem with your tests, and all these things. Are we clear? So on my end, this topic we have been looking at, this topic is going to come to an end today. So after this topic comes to an end today, I'll prepare another assignment. So you should probably have it by Monday, Tuesday, which you're supposed to work on due the other week. So the one you're doing, you submit it, then the other one due the other week. So basically that's the way we're going to work until we are done with, I think, 5 topics. If you're done with 5 topics, then you can successfully attempt an exam. Or if we are done with 5 or 4, basically if the number of topics, so right now we have done, we'll be doing 2 topics, right? Which means that is 40, because each topic is 20 marks. There will be 2 questions from each topic, that is 20 marks. So that's 10, 10, 20. If you've done 2 topics, that's 40. So each topic, 20 marks. So when you finish this topic, we are ready with 20 marks, with 40 marks. The other topic we're going to start in the coming week. Hopefully, if you finish it, that represents something like 60. Then we move on like that until we reach 5 or 6 topics. Then after those 5 or 6 topics, since you have been doing the assignments, I'll give you your test 1. Probably after 4 topics, I'll send you a test 1. You do it, you submit. Then after that again, we send you your test 2. You do it. Then we are done. Then once we're done with the test 1 and the test 2s, and the exam is done, the only thing left is the labs. But for you to attempt the labs, we need to know this information which we are discussing here. Otherwise, you trying to attempt the labs without this thing which we are discussing here, it's not going to work. So the labs will have to wait until you have written your exam, until you have done your test 1 and test 2. Then that's when you are going to have a good picture of what you're supposed to do with the labs, which are the 5 or 6 labs you're going to do. Are we clear? Yeah, the 5 or 6 labs you're supposed to do can be done over a period of 3 weeks. If we meet on a Saturday, we do 1 lab. We meet on a Sunday, we do the other lab. We meet the other Saturday, we do another lab. We meet the other Sunday, we do the other lab. We do the other Saturday, the one lab. So basically we have got up to 6 sessions. So we can do our labs over a period of 6 sessions, which is 3 weeks. So basically everything, as far as I'm concerned, we should be able to say goodbye to each other by end of, or towards the end of November or early November, because right now the next thing we're moving into is next month is what is next month is September, right? Next month is September. That's when you're supposed to write your tests, your exam. Hopefully that exam doesn't happen. If they accept your deferred thing, hopefully it doesn't happen. Then you do a deferred, then you do it. So it means your exam should probably come at the end of the exam period, which is supposed to be when is that? When is that supposed to be? Probably October. So in October, yes, in October. So in this same period, in this September, you write your test 1. You give me. Then in October, by that time, you probably write your deferred exam, and also you write your test 2. Then in that same October also, we need to push our labs. We need 3 weeks. So by the end of October, hopefully we can get done. If it's not the end of October, then the first week of November or the second week of November, everything should come to an end. Then your things will be marked. Then I submit your results to IDE. then I can get paid.
Okay.
Yeah, I get paid at the end of the year. Yeah.
Okay.
Okay, so let's start. So this afternoon we want to look at another way of what is it going to come? How to work out systems of linear equations. But this time around, what you're going to be doing is we are going to be doing something called factorization. Now, when you've got an expression, for example, a quadratic equation, where you say something, whatever x squared plus 2x minus plus whatever it is, you can factorize. You can factor out the quadratic in certain factors of maybe x minus 1 bracket then x plus 2, like that. Then if you multiply those factors, they give you back the quadratic. So basically we're going to be doing something similar to that, where we have got our matrix. In this case, we're going to be looking at the matrix A. So this matrix A, the matrix of coefficients, we'll try to break it down into a lower triangular matrix and an upper triangular matrix, so that when we multiply them, we get back our coefficient matrix. And that's what's basically referred to as LU decomposition, lower upper decomposition. It's a type of triangular factorization. There are many types of triangular factorizations which you can do, but this is one type, and that's the one we're going to look at. So the aim basically here, as I've said, we want to introduce the idea of factorizing a coefficient matrix, which is a square matrix n by n, and we want to factorize this matrix A into a lower triangular matrix L, and also an upper triangular matrix U. So the factors are going to be multiplied. If you multiply these factors L and U, we should get back our A. So basically, yeah, this is basically what the idea is. So you've got your matrix A, which, as I've said before, non-singular, and the non-singular matrix is one where the determinant of this particular matrix is not equals to 0. So this matrix A, which is a square matrix, we want to do the following. This matrix A, only the matrix A itself. The other matrix B, we're going to leave it for now, but we want to focus our attention on the matrix A. We want to split the matrix so that we can write it as a lower triangular matrix and an upper triangular matrix. And the form of these lower and upper matrices are going to be as follows. So we want our lower triangular matrix. So this is going to be our A. So this is a matrix of A. These are the coefficients: A11, A12, A13, A14, A21, A22, A23, A24, A31, A32, A33, A34, A41, A42, A33, A44. So this is our coefficient matrix. So we want to split it into this one. The one which we have here is our lower triangular matrix. Now, something is very, very familiar with this particular triangular matrix, lower triangular matrix. You notice that up here, you can look at the structure. Up here, we have got zeros. So above the diagonal, this is a diagonal here. Okay? So above the diagonal, everything is 0. The first thing you notice is that along the diagonal here, the elements along the diagonal are all 1s. How our lower triangular matrix is going to be constructed. So all the elements along the diagonal here, this is your A11, this is your A22, this is your A33, this is your A44. All these elements along the diagonal for our lower triangular matrix, they are all 1s. Do you see that?
Yes.
That's the first thing you should notice. The second thing you should notice is that under each of these ones, you have got M21, then you've got M31, you've got M41. These M21, M32, M41, they should be familiar because these are the multipliers which we were using when we were doing Gauss elimination. The multipliers we were calculating when we were doing Gauss elimination, where we whatever was here, this one we divided for this multiplier M21. We divided this A21 divided by A11 to get this. So for you to get this particular one here, you divided this to get this. You remember when you're doing Gauss elimination?
Yes.
Those multipliers. Those multipliers are the ones you put here. So M21, M3, M31, M41, then M32 here, M42, M43. So the multipliers, so the diagonal for the lower triangular matrix is full of ones. Then below each diagonal element are the multipliers you used to eliminate those particular elements in that particular column. Okay, then this other side here, what you're going to have here is U11, U22, U33, U44. This is simply an upper triangular matrix. This is what remains when you finish doing Gauss elimination. Are we clear?
Yeah.
So this is basically the process here. Yeah. Now, when we were doing Gauss elimination, we were combining the matrix A with the matrix B so that we form what we're calling an augmented matrix. That is when you're doing Gauss elimination, you combine matrix A and matrix B so that you form what is called an augmented matrix. In this particular process which you're going to be doing, you do not do that. You simply do the Gauss elimination on matrix A. You leave out matrix B. You just do the Gauss elimination on matrix A. Are we clear?
Yes.
So the Gauss elimination will go through the same steps of Gauss elimination, but this is going to be only done on matrix A. And as we'll be doing Gauss elimination, in the process of doing that, we'll be generating these values M21, M31, M41, then M32, M42, M43. These are the values we're going to put in our lower triangular matrix here. Then whatever is going to remain after we do Gauss elimination on this A, we're going to remain with this, and what is going to remain will be what you're going to be calling our upper matrix coefficients. Okay, is that clear? Is the idea clear?
Yes.
Okay, the other thing which we want to do is we have to remember what we're trying to do. We are trying to solve this. We're trying to solve AX. This is what we're trying to solve. We're trying to solve AX is equals to B. That's what we are trying to solve. We're trying to solve AX is equals to B. Now, as we are trying to solve AX equals to B, which is what we have here, we are saying that we can, if we can do this, what we're trying to do, AX equals to B, we are saying that in this particular step, before we do this step, we are going to split, before we solve this thing, AX is equals to B, we are going to split our matrix A into a lower triangular matrix and an upper triangular matrix. So we will substitute for A, we're going to put our lower triangular matrix and our upper triangular matrix. This is in place of A, then we're going to multiply with matrix X, then we're going to get B. Now, what we want, the next thing we do is this combination here. Upper triangular matrix multiplied by X. We let the product of the upper triangular matrix multiplied by X be called Y. So we call it Y. The product of the upper triangular matrix multiplied by X, we call that Y. So if we do this, we say let UX be Y, then we can write this, our lower triangular matrix, L multiplied by Y is going to be equals to B. Are we clear? Is that clear? If we say UX is equals to Y, then we can write L multiplied by Y is going to be equals to B. Is that clear? Okay, so here we're saying we let UX be equals to Y, right? Then when you do the substitution, you're going to have L multiplied by Y is equals to B. Now this Y and this X are just column matrices of unknowns. Now what we have here, this one is a lower triangular matrix. This one is a Y equals to B. So we can solve this system where you're multiplying a lower triangular matrix times a column of unknowns equals to B. So this is basically a lower triangular system. And you have seen that when we started this thing, when you're looking at triangular linear systems, we saw that if you have got a lower triangular system, you can solve a lower triangular system by using forward substitution. So this system we can work out using forward substitution. After we do this, we solve this thing using forward substitution. Then the next thing we're going to do is we're going to solve this one, because now we'll solve for y. Using forward substitution, we find what y is. After we find out what y is, then we can come and solve this one. You can come and solve ux equals to y. And we can solve for x using back substitution. So this bit here, ly is equals to b. We solve this part using forward substitution. Then this other bit, ux equals to y, we're going to solve this part using back substitution, because this is going to be an upper triangular system. Are we clear?
Yes. It's clear.
Okay. So let's see how things could look. So in this particular case, our L is our lower triangular system. Our Y is this one equals to B. So our L lower triangular system is 1. Then we've got 0, 0, 0. Then this bit, or the diagonal elements are 1s. Then under here we've got the M21, M31, M41, then M32, M42, M34. So these are your diagonal elements in this particular case. Then this is your lower triangular system, n by n. Then you multiply it by this column matrix with y1, y2, y3, and y4. This is going to be equals to B, which is your B1, B2, B3, and B4. So in this particular step, when you are splitting your A into L and U, you don't forget about the B. You only use the B at this particular step so that you can find your Y. So with this, if you multiply this bit, the first row by this column here, you end up with this. You multiply this one, the second row, by this column here, you end up with what you have there. You multiply your third row here by this column, you end up with what you have down here. What you have down here. You multiply your fourth row by the column which you have here, you end up with what you have down here. So basically, when you expand and simplify this, you end up with 1 y1 plus 0 y plus 0 y2 plus 0 y3 plus 0 y4 equals to b1. Then m21 y1 plus y1 1 y2 plus 0 y3 plus 0 y4 equals to b2. Then m31 y1 plus m32 y2 plus 1 y3 plus 0 y4 equals to b3. Then here you've got m41 y1 plus m42 y2 plus m43 y4 plus y1 plus 1 y4 equals to b1. This, when you, okay, there's a zero stuff there. When you get rid of those zero things, you end up with the following. You end up with y1 is equals to b1. Then m21 y1 plus y2 is equals to b2. Then m31 y1 plus m32 y2 plus y3 is equals to b3. Then m41 y1 plus m42 y2 plus m43 y3 plus m4 plus y4 is equals to b4. This, as we have seen in our previous cases, this is an upper triangular system, and we can solve this one quite easily, as we have said before, by doing forward substitution. So when you're doing forward substitution, we start with the first equation here, y1 is equals to b1. So this one, finding the value for y1, is just straightforward. y1 is equals to b1, and we get the value here. Is that clear?
It's clear.
Then we move on to the second part here. Now that you've got the value for y1, we're going to use the value for y1 in the second equation so that we can find y2. So y2 in this particular case, when you take this bit to the other side here, you're going to end up with y2 being equals to b2 minus m21 y1. So for y2, you're going to end up with b2 minus m21 y1. Then you substitute your value for y1, whatever value you found for y1 here. Your y1 in this case was b1. So in place of y1, you put your value for b1. So you end up with y2 is equals to b2 minus m21 b1. So you find your value for y1. You have your value for y1. You've got your value for y2. With your values for y1 and y2, then you try to work out the value for y3. So in this particular case, you move these guys, m31 y1 plus m32 y2, move them the other side, you're going to end up with y3 is equals to b3 minus m31 y1 minus m32 y2, which is what you have here. y3 is equals to b3 minus m31 y1 minus m32 y2. You already have your value for y1. Your value for y1 is this one, b1. You also have your value for y2. Your value for y2 is this one, b2 minus m2 y1. In this particular case, we have to do it like this because we don't know what the specific values are, but you're simply trying to follow through the steps. So in that particular case, you end up having y3 is going to be b3 minus m31 b1 minus m32 open bracket b2 minus m32 m21 b1. Then when you expand this bit over there and that bit over there and this one here, you end up with y3 is equals to b3 minus m31 b1 minus m32 b2 minus m32 multiplied by m31 m32 multiplied by m21 b1. Then of course you put the negative over here, you end up with y3 is equals to b3 minus m31 b1 minus m32 b2 plus this bit here. You don't really have to go this far as long as you know what the actual answers are for this particular one, because these are going to be numbers. These will come out numbers. So you just put in the numbers there, then things come out. Are we clear? So that's what you're going to do for for your y3. So now we know y1, we know y2, y3. Then we can do the same thing for finding y4. So we get these guys, m41 y1 plus m42 y2 plus m43 y3. We take them the other side, so we're going to end up having y4 is equals to b4 minus m41 y1 minus m42 y2 minus m43 y3. So when you do that, you end up with the following. You're going to end up with b4 y4 is equals to b4 minus m41 y1 minus m42 y2 minus m43 y4. At this particular stage, you already have your y1. You know what the value for y1 is. You already have your y2. You already have your y4. So you put in those values and you get your value of y4. So after you know what your y1, your y2, y3, and y4s are, that's just some unnecessary expansion. You write your expression for y as a matrix. So your y is going to be equals to y1, y2, y3, y4. So you put in your values of y here. After you put in your values of y here, now that you know what the what y is, then you start working out this one. Ux is equals to y, so that you can solve for x. So when you write this one, when you write this upper triangular system, so you're going to end up with the upper one, there will be u11, u12, u13, u14. Then here there will be 0, u22, u23, u24. Then here with a 0, 0, u33, u24, u34. Then here with a 0, 0, 0, u44. So this is going to be your upper triangular system. Then your x is going to be x1, x2, x3, x4. So this is a column vector of the unknowns, which is what you're looking for. And then this is going to be equal to the values of y you found: y1, y2, y3, y4. Then you do the expansion. You multiply this column u11, u12, u13, u14. You multiply it by x1, x2, x3, x4. You get this. You get u11 x1 plus u12 x2 plus u13 x3 plus u14 x4 equals to y1. Then this column here, second column multiplied by the second row multiplied by this column, you're going to end up with 0x1 plus u22 x2 plus u23 x3 plus u24 x4 equals to y2. Then this row multiplied by the column, you're going to end up with 0x1 plus 0x2 plus u33 x3 plus u34 x4 equals to y4. Then the last row multiplied by this column, you're going to end up with 0x1 plus 0x2 plus 0x3 equals to u44 x4 equals to y4. Then if you simplify that, then you see that you're going to end up with the following. You're going to end up with u11 x1 plus u12 x2 plus u13 x3 plus u14 x4 equals to y1. Then here you're going to end up with u22 x2 plus u23 x3 plus u24 x4 equals to y2. Then u33 x3 plus u34 x4 equals to y3. Then u44 x4 equals to y4. With this system is as we up to this stage are now aware, this is an upper triangular system. With an upper triangular system like this, where you've got these unknowns x1, x2, x3, x4, 4 of them, and with 4 equations, you can solve this using back substitution. So in this particular case, you're going to start with the last equation, this one. You start with the last equation here, then you solve for x4. So in this particular case, x4 is simply going to be equals to y4 divided by u44. So your x4 will be y4 divided by u44. Then once you find your x4, then you're going to use your x4 here. And when you use your x4 here, you transfer this to the other side so you can find your x3. So in this particular case, so it's going to be u33 x3. Then you transfer this guy to the other side, is equals to y3 minus u34 x4. Then you divide by u33. So you're going to end up with x3 being equals to y3 minus u34 x4 divided by u33. That is us doing back substitution. Is it clear what is happening and what we are doing?
It's clear, sir.
Okay. Then with x4 having been found and x3 having been found, we can use the value of x4 and x3 to find x2. So in this particular case, so here we are finding x2 from our second equation here. So these guys here, we transfer them that side, so we're going to end up having u22 x2 is equals to y2 minus u23 x3 minus u24 x4. Then you divide both sides by u22, so you're going to end up with x2 being equals to y2 minus u23 x3 minus u24 x4 divided by u22, which is what you have here. X2 is equals to y2 minus u23 x3 minus u24 x4 divided by u22, which is what you have here. Then with your value of x4, x3 and x2, you can use this now to find x1 using the first equation, which is this here. So all these guys, you take them to the other side, so you're going to end up with u11 x1 is equals to y1 minus u12 x2 minus u13 x3 minus u14 x4. Then you divide both sides by u11, so you're going to end up with the following. You're going to end up with x1 is equals to y1 minus u12 x2 minus u13 x3 minus u14 x4 divided by u11, which is what you have here. Then after that, since you have your x1, x2, x3, x4, then you write your x matrix. Your x matrix is just going to be x1, x2, x3, x4, like this. Is it clear on how these steps are going to work? Okay. Okay, so the next thing we're going to do is we're going to look at an example of how you actually do this in reality and how it works out. So the question is going to look like this. Solve the following system of linear equations using LU decomposition. So you're going to be given a linear system of equations like the one which has been given there. Then our system of equation, in this case, you've got x1 plus 2x2 plus 4x3 plus x4 equals to 21. So you've got 4 unknowns and you've got 4 equations. Then 2x1 plus 8x2 plus 6x3 plus 4x4 equals to 52. Then 3x1 plus 10x2 plus 8x3 plus 8x4 equals to 79. Then you've got 4x1 plus 12x2 plus 10x3 plus 6x4 equals to 82. So this particular system of linear equations of 4 equations with 4 unknowns, we can write as a matrix product AX is equals to B. In this particular case, the A is the coefficient of matrix, the matrix of coefficients. Then your X is the column matrix of the unknowns, the x1, x2, x3, x4. Then your B is the column matrix of the constants. So in that case, your A is going to be 1, 2, 4, 1, 2, 8. In the second row, you've got 2, 8, 6, 4. In the third row, you've got 3, 10, 8, 8. Then in the fourth row, you've got 4, 12, 10, 6. So this is going to be your A. Then your X are going to be these ones, x1, x2, x3, x4. Then your B's are going to be 21, 52, 79, 82. So in this particular thing, as we have said, where this is your A, clearly indicated, this is going to be your A, your X is this one, and your B is this one. Okay, so What we are trying to do is to split the A matrix into a lower triangular matrix and an upper triangular matrix. The lower triangular matrix is going to be made up of, above the diagonal there will be zeros, along the diagonals there will be ones, below those diagonals it's going to be the multipliers we're going to be using, we're going to be obtaining from doing Gauss elimination on A. Then the upper triangular matrix will be the result of us doing Gauss elimination on A. So we only do this on the matrix A itself. Are we clear?
Clear.
The other thing which you have to be aware of is that in this particular step, you should never try to change any rows. Don't try to interchange the rows. There is no need for you to interchange any rows.
Okay.
Yes. No interchange should be done when you're doing this. You should do things the way they are. If there is a problem because there is need for you to interchange, there is a way that particular problem is solved. And that the way of solving that problem is not by interchanging things like in this particular case. Are we clear?
Clear.
Okay, so we start with A. So this is our A. So the first row is 1, 2, 4, 1. The second row is 2, 8, 6, 4. Then third row is 3, 10, 8, 8. Then the fourth row is 4, 12, 10, 6. So this is our matrix A, and this is the one we want to split into a upper triangular matrix and a lower triangular matrix. So that with this matrix, you're going to start doing Gauss elimination. So we are going to select the first row, row number 1. We'll select row number 1 as our pivot row, and if row number 1 is selected as a pivot row, then the first element, the diagonal element in this row number 1, which is the one which you have here, is going to be our pivot element. Are we clear? So 1 is going to be the pivot element. This one, we're going to use it to eliminate the 2, we're going to use it to eliminate the 3, we're going to use it to eliminate the 4 down here. So we're going to end up with M21, M31, M41 as multipliers. So when you do that, so we start with, we have said that we're going to choose row number 1 as our pivot row, and the diagonal element A11 as our pivot element. And with that particular thing, we are going to start doing eliminations. So we're going to try to eliminate in the second row, in the first column, what's there? Everything in the first column under the diagonal element, we want to eliminate that. So the multiplier, the first one you're going to work out is M21, where we're trying to eliminate things in the second row using row number 1. So that's going to be A21 divided by A11, that's going to be 2 divided by 1, that's going to give you a 2. So your multiplier is going to be 2. This multiplier is what you're going to put in your lower triangular matrix at that particular position, M21. Are we clear?
Yes.
So already, one of the things you need to use in your lower triangular matrix has popped up here. Then after you do this, we do Gauss elimination on that particular thing. So because we want to eliminate things, so we're trying to multiply row number 2, then minus the multiplier times row number 1. So the row number 2 is 2864 minus the multiplier, which is 2 times row number 1 is 1248. So 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, 2 times 1 is 2. Then when you do that here, so we end up with we're trying to get our modified row number 2. It's going to be 2 minus 2, we're going to get a 0 here. 8 minus 4, we're going to get a 4. 6 minus 8, you're going to get minus 2. Then 4 minus 2, we're going to get a 2. So this is going to be our modified row number 2. So we get a modified row number 2, which is what we are going to put in our upper triangular matrix. And we also have got the multiplier, which you're going to put in our in our lower triangular matrix there. Next, we work out the multiplier M31. So for M31, for us to work out M31, you're going to need A31 divided by A11. That's going to be 3 divided by 1. So we're going to get a 3. So this is the multiplier we're going to use in our lower triangular matrix in the first column. Then we try to modify the third row. So the third row minus the multiplier times the pivot element, the pivot row number 1. When you do this, we should get our modified row number 3. So the third row is going to be 3 10, 8, 8 minus 3 times 1, 2, 4, 3. So 3 times 1 is going to give you a 3. 3 times 2 is going to give you a 6. 3 times 4 is going to give you a 12. 3 times 1 is going to give you a 3 here. Then when you do your things, so you end up having 3 minus 3 is going to give you a 0. 10 minus 6 is going to give you a 4. 8 minus 12 is going to give you a minus 4. Then 8 minus 3 is going to give you a 5. So this is going to be your modified row number 3. And in the process of getting this modified row number 3, we have got ourselves a multiplier which we're going to use in our lower triangular matrix L, M31. Are we clear?
Yes.
Next, we move on to work out the multiplier M41, which we're going to use to modify row number 4. So M41 is going to be A41 divided by A11. That's going to be 4 divided by 1. That's going to give you a 4. So in this particular case, this is the multiplier which we are going to use in our lower triangular matrix. And next, we do the modification of row number 4. So when you do the modification of row number 4, we end up with the following. Row number 4 modified is going to be row number 4 minus the multiplier M41 times row number 1. So in this particular case, the row number 4 is 4, 12, 10, 6, then minus 4, which is the multiplier, times 1, 2, 4, 1, which is what we have here. Then we have 4 times 1, which is 4, 4 times 2, which is 8, 4 times 4, which is 16, 4 times 1, which is 4 here. Then here, 4 minus 4, that gives you 0. 12 minus 8, that gives you a 4. 10 minus 16, that gives you a minus 6. 6 minus 4, that gives you a 2. So this ends up being our modified row number 4. So with this, we can now write our single modified coefficient matrix A as follows. So the first row of our matrix remains unchanged. Here it is. So that's 1, 2, 4, 1. This is for row number 1. Then for row number 2, we have got 0, 4, 2, minus 5. That's your row number 2 modified ones. Then for row number 3, you've got 0, 4, minus 4, 2. That's your row number 3 modified ones. Then for row number 4, you've got 0, 4, minus 6, minus 2. That's your row number 4 modified ones. So this is what you get. Okay? Are we clear?
Clear.
Next, now that everything below the first column, everything in the first column below the diagonal is equals to 0, we shift our attention to the second column, which is this one. Then the diagonal in the second column is this one here. So we want to change everything below the diagonal. We want to change these 4s. This 4 and this 4, they need to be changed into zeros. So always, when you move into a column, first column, you look at where the diagonal element is. Everything below the diagonal needs to be a 0. You move on to the second column, you look at where the diagonal is there, then everything below that diagonal needs to be 0, just like that. So in this particular case, we want to find this one here, we want to find that one. This one is going to be M32. This one is going to be, M32. Then this is going to be M42. So in this particular case, our multipliers, M32 is going to be equals to this guy divided by that, which is A32 modified once divided by A22 prime, which is going to be 4 divided by 4, and our multiplier in this case is going to be 1. So with that multiplier 1, this multiplier 1 is what you're going to put in our lower triangular matrix, but it also has got a use in modifying this row. So that's going to be our row number 3 modified twice is going to be equal to row number 3 modified once minus the multiplier M32 times row number 2 modified once. So our row number 3 modified once is 0, 4, minus 4, minus 5. So here 0, 4, minus 4, 5. That's what you have here, 0, 4, minus 4, 5. Then minus your multiplier is a 1, which is 1 in here, times your row number 2, which is 0, 4, 2, minus 5. So 0, 4, 2, 0, 4, 2 minus 5. So there's a mistake. which I've done. How could I see this? How can I understand this? Row number 2. So 04 minus 2 2. So it's me who typed something wrong. So this is supposed to be a 2. Row number 2, modified ones. The last column of row number 2, modified ones. Here, 4 minus 2 is 2. Are we clear?
Yes.
So it's supposed to be 0, 4 minus 2, 2, not 5. So you scrap out the 5 which I typed. So this 5 needs to be scrapped out here. I don't know how many times that thing, what, Jesus. Yeah. So it's already causing something then. So this is supposed to be, so okay, so it looks like I correct things here. So that's 0, 4 minus 4, 5 minus 1 times 0, 4 minus 2, 2. So here we end up having 1 times this is 1 times 0 is 0, 1 times 4 is 4, 1 times minus 2 is minus 2, 1 times 2 is 2. So 0 minus 0 is 0, 4 minus 4 is 0, minus 4 minus minus 2, minus 4 minus minus 2 is minus 2, 5 minus 2 is 3. So up to this point I think things are okay, except in the matrix there. So this is your modified row number 3 twice. Then we need to work out the other multiplier for eliminating this guy, for eliminating this one, which is M4 2. So M4 2, that's going to be equals to, the multiplier M4 2 is going to be equals to A42 prime divided by A22 prime, which is going to be 4 divided by 4 again, and you get 1 as your multiplier. So this multiplier M42 we'll put in our lower triangular matrix, but we also have a use for it here where we are modifying row number 4. So row number 4 twice is going to be equals to row number 4 double prime is going to be equals to row number 4 prime minus M42 times row number 2 prime. So when you do that, you end up having the following. So row number 4 double prime is going to be equals to 0, 4 minus 6, 2 minus 1 times 0, 4. What am I writing? What have I written? That's row number 2. Oh, okay, yeah. It's minus 4, 0, 4, 2, minus 5. Okay, good. So here, 0, 4, minus 4, 5. Then we need multiply. 1 times 0 is 0. 1 times 4 is 4. 1 times minus 4 is minus 4. 1 times 5 is 5. Then here, 0 minus 0 is 0. 4 minus 4 is 0. Minus 6 minus minus 4 is minus 2. Then here, 2 minus 3 gives you minus 3. So 2 minus 5 gives you minus 3. So this is going to be our row number 4 modified, and with this in mind, we end up with our coefficient matrix A modified twice, which is the double prime here is going to be 1. First row is going to be 1, 2, 4, 1. Then the second row is going to be 0, 4, minus 2, minus 2. Then the third row is going to be 0, 0, minus 2, 3. Then 0, 0, minus 2, minus 3. So with this, we now select the third row as our pivot row, And in this third row, we look at the third column, which is the third column, and we look at the pivot element, which is -2. So in the third row, we select the pivot element, which is -2, we select the diagonal element as our pivot element, and we use this one to eliminate the one below there. Once we do that, then we can assure ourselves that we have managed to convert our matrix A into an upper triangular matrix. Are we clear?
Very clear.
Yes. So this one here, which is here, this is M43. So M43, row number 4 being modified. Row number 4 here, we're eliminating row number 4 using row number 3 as the pivot. So our pivot element is -2, and the one we're going to get rid of is is it A prime? A double prime? A double prime 43. So our multiplier in that particular case is going to be this. M43 is going to be equal to A43 double prime divided by A33 double prime, which is equals to -2 divided by -2, which gives us a 1. So this is the multiplier we're going to put in our lower triangular matrix. And of course, we'll also use this multiplier here to modify row number 4 for the third time. So that's going to be, so row number 4, row 4 triple prime is going to be equals to row 4 double prime minus M43 times row number 3 double prime, and row number 4 double prime is 0 0 minus 2 minus 3 minus the multiplier is 1 times row number 3 double prime is 0 0 minus 2 3. So 1 times 0 gives you 0, 1 times 0 gives you 0, 1 times -2 gives you -2, 1 times 3 gives you 3. So when you come here, 0 minus 0, you get a 0 here, 0 minus 0 here, you get a 0 here, -2 minus -2, you get a 0 here, then -3 minus 3, you get a -6 here. So row number 4 modified for the third time is going to be 0 0 0 minus 6, and therefore your coefficient matrix A, when we turn it into modified for the third time, is going to be equal to your upper triangular matrix, which is going to be equal to 1 2 4 1. Then with the first row, then the second row is going to be 0 4 minus 2 2. Then the third row is going to be 0 0 minus 2 3. Then the fourth row is going to be 0 0 0 minus 6. Then your lower, so this is going to be your upper triangular matrix, the U. Your lower triangular matrix is going to have this form. L is going to be equals to, along the diagonals, you're going to have all ones. Then above the diagonals, you have zeros. Then below the diagonals, you're going to have the multipliers. M21, M31, M41, M32, M42, M443. And when you put in your multipliers, you end up with the following. You end up with your L as follows. Your L is going to be equals to 1 0 0 0, then 2 1 0 0, then 3 1 1 1 0, then 4 1 1 1. So this is going to be your lower triangular matrix. So what we have managed to do is to find the factors L and U, and we can now write our matrix A in the following fashion. We can write our matrix A, which is this one. We can write A in the form of a lower triangular matrix, which is this one, and as a product of a lower triangular matrix and an upper triangular matrix, which is this. Are we clear?
Sure, sir.
Okay, so with this, now that we have our lower triangular matrix, which is this one, and the upper triangular matrix, we go through the steps. Using the lower triangular matrix, we try to work out this system. Lower triangular matrix multiplied by y is equals to b. We know what b is, we know what the L is, and we can find out y. So using our lower triangular matrix, we work out this. This is a lower triangular matrix times your y, which is this one. This should give us a b. So when you expand, you multiply this row times this column, you get this. You multiply the second row times this column, you get what you have here. You multiply your third row times this bit, you get what you have there. You multiply your fourth row times this, you get what you have down there. Here. When you simplify this, you end up with the following. You end up with y1 is equal to 21, 2y1 plus y2 is equal to 52, 3y1 plus y2 plus y3 is equal to 79, 4y1 plus y2 plus y3 plus y4 is equal to 82. So in this particular case, when you do that, so you can now work out which one is y1. For y1, clearly, for y1, you can see your y1 is straight away 21. So y1 is equal to 21. Then using your y1 is equal to 21, you try to work out for y2. So y2 is going to be 52 minus 2y1. So your y2 is going to be equals to 52 minus 2y1. Then you put in the value for y1 here, so you end up with y2 is equals to 52 minus 2 times 21. You're going to end up with y2 being equals to 10. So now you know y1 is 21, y2 is 10. Then you try to work out for y3. So y3 is going to be y3, the equation for y3, this one, 3y1 plus y2 plus y3 equals to 79. You get these guys to the other side, so you're going to end up with y3 is equals to 79 minus 3y1 minus y2. So y3 is going to be equals to 79 minus 3y1 minus y2. That's going to be y3 is going to be 79 minus 3, y1 is 21 minus y2 is 10. So you're going to end up with y3 being equals to 6. Okay. Next, now that you've got your y1, y2, and y3, you try to work out for y4. So when you're trying to work out for y4, you'll be working out y4 from this equation, this one here. So 4y1 plus y2 plus y3 plus y4 is equals to 82. So you get these guys, 4y1 plus these guys, take them to that side. So you're going to end up with y4 is equals to 82 minus 4y1 minus y2 minus y3. So when you do that, you're going to end up with y4. Y4 is equals to 82 minus 4y1 minus y2 minus y3, and that's going to give you y4 is equals to 82 minus 4. 4, then in place of y1 you put in 21, minus in place of y2 you put in your 10, and in place of y3 you put in your 6. You're going to end up with y4 being equals to minus 18. So with that, you can write your y matrix. Your y matrix, which is equals to y1, y2, y3, y4, is going to be y1 is 21, y2 is 10, y3 is 6, and y4 is minus 18. Are we clear? Is it clear? Is it clear what you've done and what you've obtained? Hello? Is it clear what you have done here?
Come back.
Yeah.
Yes.
So this is what you have obtained for y. Using what you have obtained for y, then we're going to work out ux is equals to y. Using the upper triangular matrix, then the x and the y, so we write this this product here. So we're going to end up with the following. So our u is 1, 2, 4, 1, then 0, 4, minus 2, 2, then 0, 0, minus 2, 3, then 0, 0, 0, minus 6. This is your u. Then your x is x1, x2, x3, x4. Then your y is 21, 10, 6, minus 18. Is that clear? Next, we multiply the first row here, multiplied by this, then this second row multiplied by this column matrix, the third row multiplied by this column matrix, the fourth row multiplied by that column matrix. When you do that, you're going to end up with the following system. You're going to end up with x1 plus 2x2 plus 4x3 plus 4x4 equals to 21, 0x1 plus 4x2 minus 2x3 plus 2x4 equals to 11, then 0x1 plus 0x2 minus 2x3 plus 3x4 is equals to 6, then 0x1 plus 0x2 plus 0x3 minus 6x4 is equals to minus 18. Then when you simplify this, you're going to end up with the following. You're going to end up with x1 equals to 2x2 plus 4x3 plus x4 equals to 21. Then 4x2 minus 2x3 plus 2x4 is equal to 10. Then minus 2x3 plus 3x4 is equal to 6. Then minus 6x4 is equal to 18. So this is an upper triangular system which you can work out with back substitution. We start with the last equation here, minus 6x4 is equal to 18. So in this particular case, x4 is going to be minus 18 divided by 6. So you get your x4 equals to 3. Then once you find our x4 to be equals to 3, we're going to use this x4 in this second last equation, which is the third equation, so that we can find out what our x3 is. So we take this bit to the other side, so you're going to end up with minus 2x3 equals to 6 minus 3x4, then we divide by minus 2, so you're going to end up with x3 is equals to 6 minus 3x4 divided by minus 2. Then you put in the value for x4. We have found the value for x4 to be a 3 here, so you're going to end up with x3 is equals to 6 minus 3 times 3 divided by minus 2. You're going to end up with x3 equals to 1.5. Next, now that we have our x4 being equals to 3 and our x4 being equals to 3 and our x3 being equals to 1.5, we can use these values in the second equation, which is what we have here. So we get these guys to the other side. You're going to end up with 4x2 equals to 10 plus 2x3 minus 2x4. Then we will divide by 4 on both sides. When you divide by 4 on both sides, we're going to end up with the following. You're going to end up with x2 equals to 10 plus 2x3 minus 2x4 divided by 4. When you substitute in the values for x3, which is 1.5, and for x4, which is 3, so you're going to end up with x3 is equals to 10 plus 2 times 1.5 minus 2 times 3 divided by 4. You're going to end up with x2 being equals to 1.75. So now that you've got your x2 equals 1.75, your x3 equals 1.5, and your x4 being equals to a 3, you will now proceed to work out for x1 using the first equation. When you do that, you're going to end up with the following. X1 is equals to 21 minus 2x2 minus 4x3 minus x4, the whole thing divided by 1. You put in the values for x2 you found, which is 1.7, your x1, which is 1.5, then your x4, which is a 3. So you put in here, again end up with x1 equals to 21 minus 2 times 1.7, 1.75 minus 4 times 1.5 minus 3 divided by 1. You're going to end up with your x1 being equals to 8.5. There. So we get our column matrix X to be equals to x1, x2, x3, x4, which is equals to 8.5, 1.75, 1.5, and 3. So this is going to be your X matrix. Is it clear?
Yes.
Any questions?
So far, so good.
Okay, so we'll meet tomorrow for the last part of this thing, so that when we meet on Wednesday, then that other week we starting on Wednesday. We've got a new topic coming up, which is polynomial approximation and interpolation. So the first part of polynomial approximation and interpolation, we're going to see how we're going to use Gauss elimination to approximate polynomials. Then the second part is where we're going to use entirely new method called Lagrange interpolation to do the interpolation, and we hope we'll probably take this week and that week. So we have 3 topics, then we'll proceed like that until we come to the end of this whole thing. So if there are no questions, the moment you get done tomorrow, when you finish this whole thing tomorrow, then a new assignment is going to come. When you give you the assignment, since this one is due end of the month, the other one next Tuesday, you'll be due that other Tuesday. So we're going to be moving like that. We push in the assignments. Okay, yeah, they come. You have a week to work out the assignment, just like that, and we move forward. And yeah, hopefully we just like this, we'll get to the end of this whole thing. So it should be possible for us to get to the end. Okay. The only thing which is going to happen, I think the only thing we're going to do is when exams start. I think when your exams start, like I said, they're starting That other week, right?
Yes.
We'll scrap the Wednesday class. So we'll scrap the Wednesday class. We'll remain with only Saturday and Sunday. Okay? Yeah. So we'll remain with Saturday and Sunday. Then we're going to proceed like that until we finish.
Alright.
Okay. So see you tomorrow. So that we can finish up this bit. So that at least we have 2 topics under the bag. Okay.
Thank you so much.
All right. Cheers.